Hello guys, welcome to today's tutorials. We shall be looking at probability. So please get your writing materials ready with your calculator standby. We'll be right back. Welcome back. Earlier, we talked about probability being the likelihood of something to occur. Alright? Now, today we'll be looking at mutually exclusive events and non-mutually exclusive events. Now, what are mutually exclusive events? Mutually exclusive events are those events which cannot occur together simultaneously. That means they can't occur, they can't happen at the same time. Example is in your fair rolling of a die, you can't roll a die to get a 3 and a 5 at the same time. You can't toss a coin to get a head and a tail at the same time. Those are mutually exclusive events. Okay, now for non-mutually exclusive events, all right, they are events that can occur together simultaneously, the opposite of mutually exclusive. Okay, now examples are having a coin and a die. You can toss a coin and a die together and get a 3 and a tail, or a 5 and a head. They both are occurring at the same time simultaneously. So those are examples of mutually and non-mutual exclusive events. Now looking at addition law. Now addition law of probability. Now if the events are mutually exclusive, let's take note of that. If the events are mutually exclusive, okay, then the probability of A or either B but not both occurring. Now the probability of event A or B but not both of them occurring will become the probability of A plus the probability of B. Now if the events are mutually non-exclusive, if they are mutually non-exclusive, then the probability of A or B or both of them occurring will become the probability of A plus B minus the probability of both of them occurring. That means the difference between these two, for mutually exclusive, since both of them cannot occur, we are not having the both occurring. This one simply means the probability of both of them occurring for mutually non-exclusive. So for us to get the probability of A or B for mutually non-exclusive, we are subtracting the probability of both occurring from the individual probabilities of both occurring. Alright, let's look at examples on applications of addition of our laws of probability. Someone says a box contains 6 whites, 5 yellows, and 9 blue marbles. If a marble is picked at random, find the probability of picking 1. A white marble, 2. A yellow and blue marble, 3. A white or blue marble. Now the first question you should ask yourself is, what type of event is this? Is it mutually exclusive or non-mutually exclusive? Clearly, in picking one marble at a time, we can't pick blue and white together. Alright, since we are picking one at a time, picking yellow and blue simultaneously cannot occur. So this is a mutually exclusive event. Okay, so in summary for this, for question 1, we have probability of white. Now for us to calculate the total, we first of all calculate what's the total probability. Okay, our total ball equals to 6 plus 5 plus 9, which will give us 11 plus 9, 20 balls. So we have 20 balls in our basket or bag or box. Okay, now the probability of picking a white the probability of picking a white one will become probability of white will become how many white balls are in the box? 6 all over total 20. So let's break it down to its lowest term. Will give us 3 over 10. Now that's the probability of picking a white ball. Now the probability of picking a probability of yellow or blue. Now remember, in our mutually exclusive event, we will say that for mutually exclusive, we are having it as probability of yellow plus probability of blue. Alright, what's our probability of yellow? Probability of picking a yellow ball is 5 over 20 plus probability of picking a blue ball is 9 over 20. So if we do the LCM, we're having 20 all over 5 plus 9. And 5 plus 9 will give us 14 over 20, which will give us 2 here, 7, 2 here, 10. So the probability of picking a yellow or blue ball is 7 over 10. And to the third question, it says, what's the probability of picking a white or a blue? Okay, which brings us to probability of white plus probability of blue. Okay, now probability of white is 6 over 20 plus probability of blue, which is 9 over 20. So this will give us 20, 6 plus 9, which will give us 15 over 20. So if we break it down to its lowest term, will give us 5 here, 3, 5 here, 4, 3 over 4. Our second question says, if a number is selected at random from a set of x ranges between 6 to 20 inclusive, find the probability that it is either a multiple of 4 or a multiple of 6. Now the question you should ask yourself here is, what type of event is this? Since it is possible to pick a multiple of 4 and 6 at the same time, then this is a mutually non-exclusive event. Okay, remember we said in our mutually non-exclusive event that it is an event that can occur simultaneously together at the same time. Why exclusive events are those that cannot occur at the same time. So since we are able to pick a set of numbers from 6 to 10 that can be both multiples of 4 and 6 at the same time, then we are looking at mutually non-exclusive events. Now, let's look at our universal set. Our universal set of x will give us, since they say 6 is inclusive, x will start from 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20, since it is inclusive. Now, our set A will be multiples of 4. Our set A will be what? Multiples of 4. Now, from here, what are the multiples of 4? We have 8, 12, 16, and 20. These are the multiples of 4. Then set B will become multiples of 6. Now, what are the multiples of 6? We have 6, we have 12, and we have 18. Alright? Now, if we look at our first set, now let's know the total number of our universal set. This will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So our universal set will be 15. Okay? Now, if we look at this one, our set A will be 4 and our set B will be 3. Okay, now let's look for set A. What is set A intersection B? Now, this is the probability that both are multiples of 4 and 6. So their intersection is what is common to both sets, since they are said that it is either a multiple of 4 or 6. Now from here we can see that 12 is our only intersection. So set A and B, intersection B will be 1. Okay? Now, back to our formula that says for probability of A or B will give us our probability of A plus probability of B minus probability of A or B occurring. Okay? Now, this is where we are going to apply this. Now, our probability of A will become 4/15 plus 3/15 minus 1/15. Okay? Now, we now collect them together. If they're having a common LCM, which is 15, so this becomes 4 plus 3 minus 1. So 4 plus 3 minus 1 will give us 6/15. Now break it down to its lowest term. 3 into 6, 2, 3 into 15, 5. So the probability of this occurring will be 2/5. Alright, looking at our third question, it says the probability that team A wins a football match is 3/5 and that team B wins is 1/4. If both teams play each other, what is the probability that the match will end up in a draw? Okay, now for us to find the probability of that match will end up in the draw, we have to find the probability that both teams do not win. Okay, now the probability that A wins, is 3/5. So probability that A fails, let's put it that way, or loses, A loses, will become 1 minus 3/5, which will give us 2/5. Alright, now the probability that B wins is giving us 1/4. So probability that B loses is giving us 1 minus 1/4, which is 3/4. Alright, so now for us to find the probability that both do not win, okay? Now, probability that both do not win will become probability that A loses times probability that B loses, okay? Which is going to become 2/5 times 3/4, okay? 2/5 times 3/4, which will now give us 2 here, 1, 2 here, 2, which will give us 3/5 times 2, 10. So the probability that both of them will draw will be 3/10. Alright guys, we've come to the end of today's tutorial. Please do not forget to like, subscribe, and click on the notification button to get more updates, because the next one we'll be treating on will be the multiplication law and you won't like to miss it. So subscribe. If there be any comments, please put it in the comment section below. and will surely attend to it.